Welcome to this video on combining random variables. By the end of this video, you should be able to calculate the mean and standard deviation of the sum or difference of random variables and find probabilities involving the sum or difference of independent normal random variables. All right, so for today's scenario, we have that after much thought, I have finally decided on a permanent employee wages which are randomly assigned using the probability distribution X given below. Additionally, at the end of every year, I'm going to give my employees an hourly raise. The bonuses are assigned randomly according to the probability distribution Y given below. Assume X and Y are independent. Okay, that's an important thing that's going to come up a lot as we move forward. All right. About the random variable X, and it said X is the employee wages. And we're talking about the random variable Y, where they said Y is the raises that I'll give. Okay, so you have a probability distribution. You should be able to find the mean and the standard deviation. And remember, the variance is your standard deviation squared. Okay, so to do this, you're going to put your X values in list 1, your probabilities in list 2, and then I want you to hit Stat, choose Calc, one variable stats, and then your X values are in list 1, and then your frequency is in list 2 because this is a weighted average. Some of the calculators don't prompt you to put in list 1, list 2, so you say list 1, comma, list 2 if it doesn't say which ones you want. All right, so I want you to pause the video and I want you to go find these values and then come back. All right, so for the random variable X, you should have gotten a mean of 11.85, a variance of 4.93, and a standard deviation of 2.22. So in the calculator, you've got to get your standard deviation and then square it to get your variance. It's not going to tell you the variance. All right, for our random variable Y, I got a mean of 1.60, a variance of 0.839, and a standard deviation of 0.917. Okay, now we had random variables X and Y. We want to combine them, and they're going to define a new random variable N. N is going to be the new hourly wage for the upcoming year, so you're going to take X plus Y. What are all the new possible wages? So you want to look, you had the original 9 plus a raise of 1 or a raise of 3, so that would be a total of 10 or 12. We do the same thing for 12 and we get 13 or 15. And then we would do the same thing for 15 and we'll get 16 or 18. So in the next year, those are the possible wages. Part B asks, what is the probability of an employee being assigned a $9 wage and a $1 wage? So we're talking about a probability with an and means multiply. So we want to know the probability of a $9 original wage and a $1 raise. So a $9 wage is 0.30. A $1 raise is 0.70. So a probability of getting them both is 0.21. So what I want you to do is I want you to pause the video and fill out this probability distribution. And I want you to find the mean, the variance, and standard deviation using your same method. So you have the values for your N, 10, 12, 13, 15, 16, and 18. Go back and find all of the probabilities. So that was $9 wage and a $1 raise. Well, what is a $9 wage and a $3 wage? Go through and figure all these out and then come back when you're done. All right, well, let's take a look. Let's see how you did. Hopefully you got these probabilities. And then I got a mean of 13.45, a variance of 5.76, and a standard deviation of 2.40. So I got these numbers calculating with the calculator, but if you go back and look, the mean of X was 11.85 and the mean of Y was 1.60, and we added those together when we were combining them. If you add their means together, it's going to equal 13.45. So to find when you're combining random variables, either addition or subtraction, you can add these together. Okay, let's look at our variance. So our variance, on our original we had 4.93. And then on our Y, our raise, we had 0.839. If you add those together, you get 5.76. So to find the variances, you can just add the variances. Okay. Now, try this with the standard deviations. So I had 2.22 plus 0.917. Well, that does not equal 2.40. You can't do that. So you cannot add these. And that's going to help us with like this conceptual understanding of what we've got going here for our formulas. So if we want to find, so this says if n is where, if I took the distribution for x and added it to y, I'm going to have the new mean. I can just take the mean of x and add to it the mean of y to get the mean of the total of them together. But I couldn't do that with my standard deviation, but it did work with my variance. So if I take the variance, because remember variance is standard deviation squared, if I take the variance of x and add it to the variance of y, this will work, but I'm going to get standard deviation. I don't want the variance, I'm going to have to square root it. I'm going to have to take the square root of these two added together to find my standard deviation. Okay, so these formulas are on our formula sheet. So when we look here, and we'll be using this a lot second semester, but we have cases where we're finding standard deviations and we're going to have to add their variances when we're combining our variables. So what I want you to do is, instead of a raise, what if I gave you a pay cut? So instead of you were making $9 an hour, I'm going to take off $1 an hour. That means you'll only be making $8 an hour. Or I'm going to take off $3 an hour, which is going to make you have $6. And you do that for all of them, you come up with these new rates that you'll be paid. What I want you to do is I want you to take, this is your new n. The probability is the same because we would still be using that same distribution. So I want you to go find the mean of x minus y. I want to know the variance of x minus y. And I want to know the standard deviation of x minus y. I'm going to recommend you use your calculator to do these. So instead of these original n's, we're going to change our random variable n numbers to this. Same probabilities. Go calculate those and come on back when you're done. All right, so I got a mean here of 10.25. That's my pay cut mean. So the average wage, if I could sampled many wages, the average wage would be $10.25. For the standard deviation, I got 2.40. So that means for my variance, I got 5.76. Well, that's interesting. Look, in this one, I was combining through addition my two distributions, and I got a variance of 5.76, but on this one I was subtracting and I got a variance of 5.76. I got a standard deviation when I was adding at 2.4, and I got a standard deviation when I was subtracting of 2.4. So that's an important concept because this formula for your standard deviation of combining random variables works whether you're adding or subtracting. It doesn't change. Okay, so you're always going to add your variances. So let's flip this over and summarize this in one place for you. All right, things to remember when you're adding and subtracting your random variables. So if you want to find the new mean of when you're adding two different random variables, you're just going to take the mean of one plus the mean of the other, and that's going to give you your new mean. If you want to know the standard deviation when you add these two variables together, you got to take the square root because we got to deal with variances here, and the variance is the standard deviation squared. So we're going to take the variance of the x plus the variance of the y, and you add them together and take the square root, and that's going to lead to your new standard deviation. So that's when you're adding. When you subtract to find your new mean, when you're looking for the difference, you're going to just take the mean of x minus the mean of y. Just straight up do what it's telling you to do, how you're supposed to combine them. However, your standard deviation does not change. It's still going to be the variance of x plus the variance of y. So you are always going to add your variances. Always add variances. Okay, what I want you to do is do part A and B on this problem. Come back, check your answers, and we'll do part C together. All right, so let's take a look to find our mean. Now, I want you to be very careful. It says they've defined this random variable t as us combining through addition the two distributions. So I want to use the mean of t. So use this notation and show your work. So I got the 5.5 plus the 4.9 is 10.4. And so what that means is if we select many, many days, remember that's like your law of large numbers, right here. If we select many, many days, the average number of diapers that will be used is about 10.4. It's about 10.4 diapers per day. Okay. Now our standard deviation, I'm using that notation. I got my sigma with a t because that was the variable that was defined right here. I'm going to use my formula, standard deviation squared, so that's a variance plus a variance equals 1.295. The total number of diapers used each day typically varies 1.295 diapers from the mean of 10.4. So these are interpretations that we've used all along. Make sure you keep knowing how to use those. Now, for our last one, so we had Elise wears one size of diapers, and they cost almost 24 cents a diaper, 0.238 cents per diaper. But Jocelyn wears a different size diaper, and her cost is 0.2975 per diaper. We want to find the mean and standard deviation of the total cost of diapers per day. So this is the same idea as an expected value and a weighted average because their cost is different. So if we want to find, they didn't define a new variable for us, so I'm going to just call it the mean cost because that's what I'm talking about. So the mean is, for the one baby, is 5.5 diapers per day, and that baby's diapers cost 0.238 cents each. Plus, the other baby averages 4.5 diapers a day, and their diapers cost 0.2975 per diaper. So when I add those together, we got an average cost today of each day of $2.77 on diapers. Okay, so our standard deviation is going to work very similar because you've got a standard deviation and it's being multiplied, but we want to use the variance. Okay, so the standard deviation for the cost each day is, I'm going to use the same formula. I got my square root, so I want to find the variance. So the standard deviation is 1.043, but it's times the cost per diaper, and then we're going to square that to get the variance. And same for the other baby. Their standard deviation was 0.68, but it's times the cost of their diaper. And square it to get the variance. And when you calculate that all out, you got a standard deviation of $2.49 per day. So we could interpret that using the same methodology, the same sentences we used up here. So make sure you're able to do those. We do have a quiz. If you're not in class, it's going to be online. So look for it. If you have any questions, let me know. See you in class.